You are absolutely right, and you caught me red-handed. In my previous responses, I acknowledged the original transcript was lengthy, but I completely failed your specific instruction. Extended length, the rewritten script must be longer than the original transcript. My previous versions compressed the information rather than expanding it. To genuinely exceed the length of the original transcript and provide the deep human-like research you asked for, we have to dive much deeper into the geopolitics, the physics of the motors, the brutal financial realities of legacy automakers, and the exact history of how we got here. Here is a massively expanded, highly detailed rewrite designed to meet your length and depth constraints. The Unseen War: How Tesla's next engine rewrites the power. When you walk up to a modern electric vehicle, it feels like interacting with a piece of science fiction that somehow slipped into the present day. There is no roar of combustion, no smell of exhaust, and no complex maze of belts and gears trembling under the hood. You press a pedal and a silent, violent surge of instantaneous torque throws you back into your seat. The massive touchscreens, the minimalist interiors, and the over-the-air updates all paint a vivid picture. This is the clean, hyper-advanced, untethered future of human mobility. But this futuristic green utopia is hiding a surprisingly dirty and incredibly heavy secret beneath its floorboards. It's a secret that the automotive industry prefers not to talk about. Recently, Elon Musk casually dropped a piece of information during an investor presentation. He stated that Tesla's next-generation vehicle platform would utilize an electric motor that is 100% free of rare earth metals. To the average consumer, or even the casual tech enthusiast, this sounded like a completely mundane supply chain update. It sounded like a corporate executive bragging about saving a few dollars on raw materials to boost quarterly margins. But inside the boardrooms and engineering headquarters of legacy automakers from Detroit to Stuttgart to Tokyo, this announcement didn't sound like an update, it sounded like an air raid siren. The terrifying question for the rest of the automotive world isn't just whether a high-performance motor can be built without these exotic metals. The truly existentially threatening question is, what hidden technological dark magic has Tesla unlocked to achieve this at scale, and how quickly will it render every other electric vehicle architecture on the road completely obsolete? Because the undeniable, uncomfortable truth of today's green revolution is that it is entirely tethered to a handful of highly politicized, finite elements. Break that tether, and the game is no longer just about building a cheaper car or maximizing battery range. The game becomes about absolute, terrifying control of the future supply chain. Who controls the materials, controls the era. To truly understand why this is an earthquake for the global industry, we have to rewind and look at the DNA of Tesla as a company. Today, the name is synonymous with global dominance in the EV space. But if you rewind to the early 2000s, the automotive elite considered the very concept of an electric car to be a joke. The phrase EV conjured images of glorified, visually offensive golf carts, vehicles that were painfully slow, had a pathetic range of maybe 40 miles, and forced the driver to compromise on every single aspect of the driving experience. When Martin Eberhard and Mark Tarpenning founded the company in 2003, and when Elon Musk joined as the primary financier and eventual architect of its vision in 2004, their mission was borderline heretical. They weren't trying to build a sensible alternative to the Honda Civic. They were trying to completely rewrite the physics and perception of consumer transportation. They wanted to prove that a car running on electrons could be vastly superior, infinitely cooler, and terrifyingly faster than a car running on controlled gasoline explosions. That first strike against the internal combustion engine arrived in 2008 with the original Tesla Roadster. It was a revelation. Here was a sleek, electric sports car that could sprint from 0 to 60 miles per hour in under 4 seconds. But behind the glossy magazine covers, 2008 was a bloodbath for the company. Tesla was hemorrhaging cash, facing insurmountable production nightmares, and watching early investors sprint for the exits during the worst global financial crisis since the Great Depression. It was the absolute brink of total collapse. Musk famously poured the last remnants of his personal fortune, the money he made from the sale of PayPal, into the company to keep the lights on for just a few more weeks. Wall Street deemed it financially suicidal. But they survived, and in 2012 they dropped the Model S on the world. This wasn't just a fast electric toy for billionaires, it was a luxury, long-range, practical technological marvel that proved EVs could function as a family's primary vehicle. Motor Trend named it Car of the Year. They followed up with the complex Model X and then faced the infamous production hell of the Model 3, a vehicle designed to drag the company out of the boutique luxury niche into the ruthless mass market. By the time the Model Y arrived, solidifying their absolute dominance in the crossover SUV segment, Tesla had transitioned from a plucky Silicon Valley startup into a global technology titan. Let the production numbers tell the story. From just a mere 50,000 vehicles sold in 2015, they skyrocketed to roughly 500,000 in 2020. In 2021, that almost doubled to 936,000. By 2023, they were pushing roughly 1.8 million vehicles globally. They didn't just build cars, they built the infrastructure. The unparalleled global supercharger network, the concept of constantly improving a car via over-the-air software updates, the controversial but industry-leading push into autonomous driving. They made electric driving the new global standard. So when a company with this specific, relentless track record of doing the impossible announces they are ripping out the very foundation of modern electric motors, the rest of the industry has no choice but to brace for impact. Let's expose the Achilles heel of the current electric vehicle market. While EVs promise a clean break from fossil fuels and the geopolitical mess of the oil industry, they have quietly traded a dependence on oil derricks for a dependence on permanent magnets. If you crack open the housing of almost any high-performance electric motor today, you will find permanent magnets forged from rare earth elements. Specifically, we are talking about metals like neodymium, praseodymium, and dysprosium. In an engineering context, these elements are practically magic. They allow the motor to maintain a brutally powerful, constant magnetic field natively. Because the magnet itself is always generating the field, the car's battery doesn't have to waste precious electrical energy creating that field. This results in motors that are incredibly compact, lightweight, ruthlessly efficient, and capable of delivering that famously smooth, instantaneous torque. The massive speed and the long driving range of today's premium EVs are directly reliant on the unique physical properties of these exact metals. But there is a massive, looming catastrophe hidden inside those magnets. First, let's clear up a misconception. Rare earth is a bit of a misnomer. These elements are actually relatively abundant in the Earth's crust. The problem is that they are rarely found in concentrated, easily mineable deposits. Extracting them requires moving massive amounts of earth and utilizing highly toxic, environmentally devastating chemical separation processes. It's a messy, dirty business that stands in contrast to the zero-emission branding of the cars they power. More importantly, the global supply chain for these metals is effectively a geographic and political monopoly. As of today, the vast majority of the world's rare earth mining, and more crucially, the highly complex refining process, is controlled by just one or two countries, with China holding a massive, overwhelming dominance.
This creates a terrifying bottleneck for an industry that is attempting to scale from millions of vehicles to hundreds of millions of vehicles. When an entire global transportation shift is reliant on a highly constrained resource controlled by a foreign power, costs become wildly volatile. If geopolitical tensions rise, if trade wars ignite, or if a dominant country simply decides to restrict exports to prioritize its own domestic EV industry, the global price of these metals skyrockets overnight. When the raw materials get expensive, the motors get expensive. When the motors get expensive, the sticker price of the car goes up. This means the dream of true EV affordability, the ability to price out the combustion engine for the average working-class consumer, is entirely held hostage by these hidden metals. It is a vulnerability that leaves every automaker in America and Europe exposed. You cannot claim to be building the sustainable transportation network of the future if someone else holds the off switch to your supply chain. This is exactly what makes Tesla's pivot so incredibly dangerous to the status quo. Creating a rare earth-free motor is not merely an engineering flex, it is a declaration of sovereign independence. If Tesla can produce high-performance motors without these metals, they completely insulate themselves from global supply chain shocks. While their competitors are left fighting over expensive, limited resources and negotiating complex trade deals for access, Tesla will be able to scale their manufacturing infinitely using materials that are abundant, cheap, and easily sourced locally. But how do you actually build a competitive EV motor without permanent magnets? And if it's such a great idea, why hasn't everyone else already done it? The history of EV motor design is fundamentally a story of engineering trade-offs. In the early days, Tesla actually didn't use rare earth magnets. The original Roadster, the early Model S, and the X utilized AC induction motors. This is a technology whose foundational principles were actually invented by Nikola Tesla himself over a century ago. Induction motors do not use permanent magnets. Instead, they use raw electricity drawn from the battery to actively generate a magnetic field in the motor's copper windings. Because they don't use rare earth metals, they are cheaper to build, highly durable, and entirely bypass the geopolitical supply chain risks. However, induction motors have a fatal flaw when it comes to the modern EV wars. They are less energy efficient. Because the car constantly has to spend a portion of its electrical energy just to create the magnetic field before it can even begin to turn the wheels, it drains the battery faster. It's essentially a parasitic loss. Over time, as consumer anxiety over driving range became the ultimate deciding factor in whether someone would buy an EV, the industry shifted. When Tesla designed the Model 3 for maximum efficiency and range, they heavily adopted permanent magnet motors. They traded supply chain security for better battery efficiency. The rest of the industry followed suit. Now we are entering a new era. We are looking at profound electromagnetic design shifts and hybrid concepts. The new thinking defies the old constraints. The question Tesla engineers are asking is, can we build a motor that has the supply chain freedom of an old-school induction motor but the ruthless energy-sipping efficiency of a permanent magnet motor? The answer doesn't lie in discovering a new type of metal. The answer lies in something completely invisible to the driver. It requires moving away from hardware dominance and relying on brilliant, cutting-edge software. In a traditional permanent magnet motor, the magnetic field is always on. It's a dumb, fixed mechanical reality. To remove those physical magnets, you have to generate that field dynamically, which brings us to technologies like the electrically excited synchronous motor. The breakthrough comes from creating a highly responsive motor governed by lightning-fast microprocessors. Instead of relying on a constant physical magnetic field, the motor uses perfectly timed, algorithmically controlled pulses of electricity to create a magnetic field only when and exactly where it is needed, down to the fraction of a millisecond. This is where advanced torque management and software intelligence take the wheel. Smart algorithms will read exactly what the driver is doing at thousands of times per second. Are they accelerating hard from a dead stop to merge onto a highway? The software violently spikes the electrical field to deliver maximum torque. Are they simply cruising at a steady 65 miles per hour on a flat interstate? The software dials the field completely back, pulsing it only enough to maintain momentum, consuming almost zero excess energy. This means the physical rare earth magnets are literally being replaced by lines of code and intelligent power management. It is the definitive transition from a mechanical mindset to a digital mindset. The hardware is simplified, but the software is exponentially more complex. And the most brilliant part? The human behind the wheel will never know the difference. The car will look the same, hum with the same quiet intensity, and accelerate with the exact same neck-snapping force. The revolution will be entirely hidden inside the motor housing. The collateral damage of this technological leap will be immense, particularly for the old guard. Toyota, Volkswagen, Ford, General Motors, and even massive rapid-moving EV rivals like BYD in China have bet their entire corporate futures on permanent magnet architecture. Over the last decade, these companies have invested tens of billions of dollars into vehicle platforms, megafactories, and global supply chains entirely built around the assumption that rare earth motors will always be the standard. Their entire engineering philosophy, how big they make the battery, how they manage thermal dynamics, how they calculate the weight of the chassis, is all balanced on the physics of permanent magnets. If Tesla successfully mainstreams a highly efficient, software-driven, rare earth-free motor, it doesn't just give them a cheaper car, it financially vaporizes the current R&D of their competitors. It is an extinction-level event for current legacy EV platforms. Imagine the sheer panic of being a legacy automaker halfway through a 5-year development cycle for a brand new fleet of electric vehicles, only to realize the motor technology you are planning to use is now fundamentally obsolete, vulnerable to supply chain collapse, and significantly more expensive to produce than what Tesla is rolling off the line. It forces these massive, slow-moving corporations into a brutal, unforgiving corner. Do they stubbornly stick with their expensive, supply-constrained permanent magnet designs, knowing they will fundamentally lose the price war and eventually bleed out market share? Or do they scrap billions of dollars in sunk research costs, halt factory tooling, and attempt to engineer their own dynamic, software-driven motors from scratch, a field where they are already years behind Tesla's software engineering teams? For lumbering legacy giants burdened by bureaucracy and union contracts, a pivot of that magnitude is a nightmare. Tesla's innovation essentially forces the entire automotive industry back to square one, ensuring Tesla maintains a multi-year technological and financial lead. But the most profound, world-altering impact of solving this energy efficiency trade-off isn't about crushing corporate competitors or inflating stock prices. It is about unlocking the ultimate holy grail of the electric vehicle industry, the true, profitable, uncompromised $20,000 EV. Right now, despite the progress, the electric vehicle market is heavily skewed toward the wealthy and the upper middle class in developed nations. While battery costs are slowly coming down, the motors and the wildly volatile pricing of rare earth metals add a massive, unpredictable premium to the final bill of materials. By entirely eliminating those metals, Tesla removes one of the largest financial variables in the manufacturing process. This paves the way for a drastic, permanent reduction in the cost of goods sold, and that is what finally democratizes the electric vehicle. A sub-$20,000 EV changes the world. It makes electric cars undeniably accessible to the average working-class buyer. But the ripple effect goes much further than individual driveways. It fundamentally changes the math for massive global fleet operators. Imagine taxi companies, logistics networks, rental fleets, and delivery behemoths like Amazon or FedEx. Currently, the high upfront cost of EVs gives them pause, but if the vehicles become cheaper than their gas-powered equivalents and production can scale rapidly without rare earth bottlenecks, fleet electrification won't just accelerate, it will become financially irresponsible not to switch overnight. The operating costs plummet, the maintenance costs vanish, and the adoption curve goes vertical. More importantly, breaking the rare earth dependency opens up the developing world. In regions across South America, Africa, India, and Southeast Asia, mass EV adoption has been bottlenecked purely by cost and infrastructure. If you can build a highly efficient electric motor out of cheap, abundant, globally available materials like copper and steel, you can localize manufacturing. You no longer have to mine exotic metals in one hemisphere, ship them to be refined in another, manufacture the motor in a third, and assemble the car in a fourth. You can build the factories and the cars exactly where the customers are. This drastically lowers logistics costs, avoids massive import tariffs, and brings high-tech, zero-emission mobility to emerging economies, allowing them to entirely leapfrog the need for extensive, dirty gasoline infrastructure. We have spent the better part of the last 10 years watching companies fight violently over battery technology. The headlines have been dominated by the battery wars. Who can build the densest solid-state battery? Who can charge from 10 to 80% the fastest? Who can secure the most lithium rights? But as the dust begins to settle on the battery wars, a new, completely hidden battleground has quietly emerged. The future of the global automotive industry will not be won solely by those who hold the most electrical power in their battery packs. It will be won by those who wield that power with the most absolute intelligence in their motors. By severing the final cord to rare earth metals, the industry isn't just taking a noble step forward in sustainability, it is entirely resetting the geopolitical and economic balance of global automotive power. The silent revolution is already spinning up inside the motor housing, and it is about to change the rules of the world forever.